Alright, so in this video we're going to do simplifying square roots, but the important part here is we're going to leave our answer in exact form. So we are not looking for decimals. So in the past you may have done a lot of the times with like Pythagorean theorem back in like 8th grade, or whatever grade that you did mainly Pythagorean theorem, you may have gotten a square root and then you stuck it in the calculator and you estimated it. We are no longer going to do any estimating. So we need to know some properties of square roots. So to do simplifying, one of the things you need to know is just its simple property and another little thing we're going to talk about later. So here we go. Square root of a times b, which simply means, okay, so when I have this written in this form, what you need to know is what we're trying to say to you is that this is a product, okay? So when written in there algebraically, if I have the square root of a product, now what's a product? A product is the answer to a multiplication problem. So what I'm allowed to do is by definition here, I'm allowed to take the square root of a and multiply it by the square root of b. And now I've broken it apart from being a product, and what I'm claiming is that this is a factor and this is now a factor, okay? So much like you have done in the past, that you had when you multiply two things together, it makes a product, and the things you multiply together are called factors, we're following that same property with square roots. So in the problem down here, this idea of the meaning, okay, I'm just going to show you what it means to do that. So our product is 12. So I could write this if I wanted to as the square root of 2 times the square root of 6. Okay, or, okay, I could write this as the square root of 3 times the square root of 4, okay? Now, in the terms of simplifying a square root, one of these groups, okay, one of these groups is better than the other, and we'll talk about that in a little bit. But anyhow, what I want to point out to you here is, notice I did not use 1 and 12. Using 1 and 12 as in a square root is redundant because it still leaves a 12 underneath the square root. And when simplifying the square roots, basically what we're trying to make is the number underneath smaller, all right? So the next thing we need to know, all right, about square roots is that a perfect square, so if I have a perfect square number, that if I try to take the square root of a perfect square, that will always give me a whole number. So what we're going to list off here is our perfect squares, and what we have here is a list of our perfect squares, and I will tell you how you get them. 1 is gotten by doing 1 times 1. So 4, okay? 4 is created by doing 2 times 2. And then number 9 is created by doing 3 times 3. 16 is created by doing 4 times 4. So the perfect square, if I take the square root of it, the perfect square, they have these things called roots. So they're called roots for the acronym or nickname as that we're taking a radical, which is a square root of a function. So the roots of the perfect squares I'm going to list above them here. So that's 1. The root of 4 is 2. The root of 9 is 3. The root of 16 is 4. The root of 25 is 5. The root of 36 is 6. The root of 49 is 7. And the root of 64 is 8. The root of 81 is 9. And the root of 100 is 10. So basically, if you notice here, what I'm doing is if I take my whole numbers, okay, and I multiply them by themselves, you make a perfect square. So a perfect square by definition is literally a whole number that gets multiplied by itself. So when you take the square root of a perfect square, you get back its whole number used to multiply it. So I hope that makes sense. But we're going to go ahead and we're going to do some examples with simplifying these things, and that's the goal, is to write these things in exact form. All right, so on to the next one. So here we go. We're going to do some simplifying. So the idea I have here is I have 9 problems. And the goal here is to go through these 9 problems, leave them in exact form. So the way that you do this is you use perfect squares. So 8 we could write as the square root of 2 times the square root of 4. All right, so notice the factors. So the factors of 8 are 2 and 4. Now, from here, the square root, okay, is asking you, do you have a perfect square? And the answer to that is yes. The square root of 4 is 2, right? So the root of 4 is 2. So I take the square root of 2, I multiply it by 2, and what I get left with is 2 square root of 2. Now notice I took this 2 and I plopped it out front. The reason I plopped it out front is because this is the standard way of writing a simplified radical in exact form. When you have a radical left in the answer, we write the radical after the whole number. All right, so number 2. So number 2 is the square root of 12. Now, the square root of 12, if we take a look at its factors to make 12, so what are two numbers that multiply together to make 12? We could have used the square root of 2 and the square root of 6, but notice neither 2 nor 6 are perfect squares. So in the last video, the last screen that we were on, all right, I also had the square root of 3 times the square root of 4. And now this one was no good because it left me with no perfect squares, but this one I now like. And the reason I like it is because it has the square root of 4 in there. And the square root of 4 is 2. So my final answer here will be 2 square root of 3. And then I'm done. So basically when you're simplifying a problem, what you're trying to do is you're trying to find the largest square root, okay, the square number that goes into it. So now 50. So what are two things that multiply together to make 50? So 1 and 50, great. You could have used square root of 2 times the square root of 25. You could have used the square root of 5 times the square root of 10. All right, and those are your basic answers. Now, the square root of 5 and the square root of 10 I would not use because neither 5 nor 10 are perfect squares, so I wouldn't use this one. But I would use this pairing up here, square root of 2 and the square root of 25, and the reason for it is because 25 is part of our perfect squares. If you take 5 times 5, you get 25. So the root of 25 is 5, and I multiply that by the square root of 2 because that root is left and it is not a perfect. So there it is. I'm finally done. All right, so on to 75. So this number 4. So number 4 says the square root of 75. So I think about to myself, what are two ways or two numbers that I could use to multiply 75? So I've got square root of 3 times the square root of 25. And I think of some other numbers, and I can't think of any. Okay, because notice I'm always skipping over 1 and itself. I don't want to use 75 and 1 because it doesn't make any sense to do so. So in this case, we just talked about the last problem, root of 25. Root is 5, so this is 5 square root of 3. So notice all we're doing here is playing a game with factors, and that's it. And when we find a factor that's a perfect square, we write it as its root. So if you need to remember that, you need to rewind back to that beginning problem. You should write that list down, okay, to help you. So 108 is the next one. So 108. So what are all the ways that you could make 108? So you could use the square root of 2 times the square root of 54. And that's not going to be helpful, okay, because neither 2 nor 54 are perfect squares. But if we take a look at the next one, which is 3, so the square root of 3, 3 also goes into this. Okay, if you want to know a neat trick for if a number is divisible by 3, add up the digits. So 1 plus 0 plus 8 makes 9, and therefore it is divisible by 3. So I take that, and I take the square root of 3 times the square root of, it's 36. Okay, and then I look at this, right, and I can keep going. So 108, if I divided it by 4, all right, also goes in, so I can take square root of 4 times the square root of 27. How about 5? I don't know. How about 6? So let's take 108 divided by 6, and you get 18. Square root of 6 and square root of 18. Okay, and then 7, does 7 go into this? I don't think so. 7 doesn't. How about 8? 108 divided by 8. So I'm just checking now on a calculator. 8 does not. How about 9? 108 divided by 9, and you get 12. Square root of 9 times square root of 12. Okay, and I don't think there's any others. 10 and 11 surely don't. All right, so here are all of my pairs. Now, When I take a look at these pairs, 2 and 54 I'm crossing out because neither of them are perfect squares. Okay, I'm also going to cancel out this 6 and this 18. All right, because neither of those are perfect squares. However, look at the 3 that are left. 36 is a perfect square, 4 is a perfect square, and 9 is a perfect square. Now, the key to this is, okay, the last 3 that I have left all have a factor that is a perfect square, okay? But what I want to choose is I want to choose the one that is the largest number. So I look at 4, compare it to 9, and I go, well, 4 can't surely be it. And then I take a look at 9 versus 36, and 9 surely can't be it. So the largest perfect square in this list is made up of the square root of 3 and the square root of 36. Now, the square root of 36, because it's a perfect square, has a root. Its root is 6. And then that you just write times that by the square root of 3, and you're left now as a simplified form in exact form. So notice I am not typing this in a calculator to analyze the square root of the number. I'm typing it in a calculator to figure out what numbers go into it. All right? So now I go to 128. So again, 128, divide that by 2, you get 64. So square root of 2 times the square root of 64. And at this point, what you should begin to notice is that the farther the number is up the list, the higher its root will be. So this one happens to have a 64 right in the beginning, which means the largest possible answer to having a root, and there's other numbers that go into 128, but not one of them is ever going to be a number larger than 64. So in this problem, I'm already done just by dividing it by 2. So in this case, the square root of 64 the root of 64 is what number multiplies together to make 64, and that's 8 times 8. So the root of 64 is 8. So I write an 8. Oops, sorry, change colors there, by write an 8, and I multiply that by the square root of 2, and then I leave it. Remember, exact form does not take a square root of a number in a calculator to get its decimal. So down the number 7. So it says 300. So if you take 300 and divide it by 2, you get the square root of 2 times the square root of 150. Now, 2 nor 150, are they perfect squares? Nope. So what are other two numbers? So the square root of 3 times the square root of 100. So are either of these a perfect square? And what you have here is that 100 is a perfect square because it's 10 times 10. So the root of 100 is said to be 10. So then I leave my final answer is 10 root 3, and then I'm done. Okay, on to the next one, number 8. So number 8, so if you notice here, all I'm doing is writing out what are two numbers that multiply to get it, and then I'm just trying to figure out of this list, okay, what is the highest number? So I always start at 2. I go 2, then 3, then 4, then 5, then 6, then 7, then 8, and I keep going until I find the largest square number. Now, if you always start at 2 and then go to 3 and then a 4 and then a 5, I will tell you that every time in the list, the first one that has a partner that is a perfect square that pops up is always going to be the highest. Okay, and that example, the best noted that one was in example 5 here, when I could have just stopped at 3, because when I find the first one, okay, if you follow the method of dividing it by 2, then 3, then 4, then 5, then 6, okay, you will always find that you get the highest one quickest. Okay, so continuing with all this last one here. So it has the square root of 162. So I start off my problem with dividing it by 2. So square root of 2. So can I multiply 2 times what? Okay, and that's the 81. So square root of 81. Now is 81 a perfect square? And the answer to that is yeah. 81 is made by multiplying 9 times 9. So the root of 81 is 9. So I write this as 9 square root of 2, and then I'm done. All right, so on to 245. So 245 is not divisible by 2. Is it divisible by 3? So 245 divided by 3? Nope. How about 245 divided by 4? Not going to work. How about divisible by 5? And the answer is 245 divided by 5 is 49. So notice that I'm just going through my integers, going 2, 3, 4, 5, 6. So I got the square root of 5 times the square root of 49. Now, are either of these perfect squares? And yes, 49 is a perfect square because it is 7 times 7. So we take the square root of that and we find that its root is 7, and we write it as 7 root 5. And then we're done. We have now simplified. Now, there are other ways to do these problems, but I find that this to be the easiest method because you're just looking for two numbers that multiply, but you gotta start, okay? You gotta start at 2 and then go to 3 and then a 4, and you're just checking, is it divisible by that? And once you find it partnered, the first number that when you do that, you find partnered with a square number, that will be your answer. All right, you take the root of the square and you will find that your answer is left. So I hope that was helpful. And yeah, so take it easy and we'll go from there. All right.